up, team? And welcome back to it, man. Welcome back to Herbs class for 5 more minutes of math. And we're still with this factoring thing, right? So factoring is like laundry. You're gonna find out real quick, like it's never gonna end. There's always more to do. So if you've been with me for a little while, we've already talked about factoring the difference of squares. Now, if you can factor a difference of squares, you can also factor a difference of cubes. Yes, a difference of squares and difference of cubes is actually very similar. And you know how I like to do. Let's get one up here. Okay, good. Yep, you got it. You are looking at a difference of cubes. So just like back when we did a difference of squares, let's do a checklist real quick to make sure we're looking at a difference of cubes. So first off, 2 terms, exactly right. Now, if we're working with a difference, it's going to be the difference between 2 terms. Speaking of that difference, remember what that subtraction sign meant? Of course, subtraction means the difference. So I have the difference between 2 terms. Now those 2 terms now, instead of having to be in perfect squares, they got to be, yes, perfect cubes. Now, if squares are raising things to the 2nd power, cubes are raising things to the, exactly right, raised to the 3rd power. When it comes to numbers, we're talking about 1 to the 3rd, 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, or 1, 8, 27, 64, you get it. And when it comes to variables and exponents, your exponents have got to be either 3 or a multiple of 3, because I can take the cube root by dividing that exponent by 3. Yeah, go ahead back and watch them exponent rules videos. Okay, so right here, we have a difference of cubes. Now, luckily for us, there's a super helpful formula. Let me show you how to use it, but let me show you the formula first. Okay, good. So here's the formula. Now, let me explain to you what A and B are. So when we have a difference of cubes, what we have are 2 things being cubed and the difference between them, right? So it's going to be up to us to kind of figure out what is the thing being raised to the 3rd power, because notice here in my formula, A is being raised to the 3rd power, and then we make reference to A through the rest of the formula. Yeah, so what that means is whatever that thing is that's being raised to the 3rd power is A. So quick example right here. What thing is being raised to the 3rd power here? Let me rewrite this so it's easier to see. Yeah, X is being raised to the 3rd power. Now, it's not that easy here, but if we think real hard, what number raised to the 3rd power is 27? 3 raised to the 3rd power is 27, so I could rewrite it like this. Now I know exactly what A and B are. Yeah, as far as this formula goes, X is A and 3 is B. So now all I have to do is go back here and replace my A with X, my B with 3, just like this. Notice I replaced every A in my formula with the letter X, and I replaced every B in my formula with the number 3. And now we just simplify. Let me get this stuff out of the way and clean this up. Just like that, right? Because X times 3 is actually 3X. And here I have factored my difference in cubes. Yeah, let's kick it up a notch. Ooh, I like this. So first off, let's check, make sure. 2 terms, difference, good. Is this a perfect cube? Well, can I take the cube root of 8? 8 is 2 to the 3rd power. Yeah. X to the 6th power. I got to be able to divide that exponent by 3. Can I? Yeah. So X squared to the 3rd power will be X to the 6th. Yeah. And of course, that's Y being raised to the 3rd power. So let's set that up. Let's show that now. Good. So 2x squared is that thing being raised to the 3rd power. So that's what I'm going to substitute for A. Yeah. Y is that thing being raised to the 3rd power. So that's what I'm going to substitute for B. Just like this. Yes, just like that. So notice everywhere there's an A, I replace that A with a 2x squared. Everywhere there's a B, I replace that B with a Y. Now let's just clean this up. Good, that's exactly right. Now, remember before we could only do a difference of squares, we couldn't do the sum? Cubes ain't like that, no. You can do the difference of cubes, you can also do